Welcome to True Projects. In this video, we are going to explain about the project titled Chronic Kidney Disease Stage Identification in HIV infected patients using machine learning. Introduction. CKD, chronic kidney disease, is a long-term health condition that progresses slowly over time. It often shows no noticeable symptoms in its earlier stages, making it challenging to detect. As CKD advances, it raises the risk of other serious health issues, including heart failure and anemia. Understanding CKD's gradual development and its associated health risk is crucial for timely intervention and effective management. CKD can be challenging to diagnose earlier because symptoms are often absent or subtle. Individuals with HIV are at a higher risk of developing CKD, and detecting CKD in these patients can be even more critical due to the advanced stage of the disease. Highlighting the difficulty in earlier CKD detection underscores the need for advanced tools like machine learning to aid in the identification of CKD stages in HIV-infected patients. Machine learning is a powerful tool in healthcare. By leveraging this technology, we aim to develop a predictive model capable of assisting healthcare professionals in determining the stage of CKD in HIV patients. This project addresses the critical need to provide healthcare providers with a data-driven approach to identify CKD stages promptly. Earlier detection allows for timely interventions and tailored treatment plans, ultimately improving the quality of life for HIV-infected individuals facing CKD. Objective. The primary objective of this project is to employ machine learning techniques to predict the stages of chronic kidney disease (CKD) in individuals diagnosed with HIV. Accurate predictions play a vital role in enabling timely medical interventions and ensuring more effective management of CKD in these specific patients. Earlier identification and classification of CKD stages empower healthcare professionals to tailor treatment strategies, potentially improving health outcomes and quality of life. To enhance the accuracy and effectiveness of stage prediction for CKD in HIV patients, a wide array of machine learning algorithms is utilized. These algorithms include random forest, decision tree, KNN, K nearest neighbor, support vector machine SVM, voting classifier, ADA-boost, XG-boost, CNN plus LSTM, and CNN. Each algorithm offers a unique approach to understanding and interpreting the data, collectively contributing to a comprehensive and robust prediction model. The employed machine learning algorithms systematically analyze patient data, discerning intricate patterns and correlations related to the stages of chronic kidney disease (CKD). This analysis is based on historical data that provides valuable insights into how various features or variables relate to different stages of CKD. By recognizing these patterns, the model can make accurate predictions for new patients, guiding healthcare professionals in appropriate decision making and facilitating a more tailored approach to managing CKD in HIV-infected individuals. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, essential libraries and packages for Python are imported, such as Pandas for data manipulation, NumPy for numerical operations, Seaborn and Matplotlib for data visualization, and scikit-learn for machine learning tasks. Importing these packages ensures that the necessary tools and functions are available to work on the dataset and perform subsequent tasks effectively. Exploring the dataset. Chronic kidney disease prediction. Here, the dataset related to chronic kidney disease is loaded and explored. This involves understanding the structure of the data, the types of features available, and the distribution of data. Exploratory data analysis (EDA) is performed to gain insights into the dataset, which is crucial for making informed decisions in the subsequent stages of the project. Data processing. In this step, the dataset is processed to handle missing or null values. Any records with missing values are either removed or imputed with appropriate techniques to ensure the dataset is clean and ready for analysis. Data dropping if any null values. Data visualization using Seaborn and Matplotlib. This module involves creating visualization using Seaborn and Matplotlib. Visualization techniques like histogram, bar plots, correlation matrices, and scatter plots are utilized to better understand the dataset's features, relationships, and distributions. Visualizations aid in making data-driven decisions and in conveying insights effectively. Data cleaning. Data cleaning involves preparing the dataset for model training. This includes converting categorical data strings into numerical format using label encoding, a necessary step for feeding the data into machine learning models that require numerical input. Label encoding for string to int or float. Feature selection. Feature selection is the process of choosing the most relevant features for model training. It ensures that the model focuses on the most influential aspects of the data, leading to more efficient and accurate predictions. Splitting the data into train and test. The dataset is divided into training and testing sets. The training set is used to train the machine learning models, while the testing set is used to evaluate their performance. This step is critical for assessing the model's ability to generalize to unseen data. Building the model, in which we have different algorithms. The first algorithm which we have used in this project is random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training. It predicts the CKD stage by aggregating predictions from these trees. In this project, random forest is used for its ability to handle a variety of data, find complex patterns, and generally provide high prediction accuracy. Decision tree. A decision tree is a flowchart-like structure where each internal node represents a feature or attribute, and each leaf node represents a decision. It's a straightforward model that can handle both numerical and categorical data. In this project, decision tree helps predict CKD stages based on specific patient attributes. KNN, K nearest neighbor. KNN is a simple and intuitive classification algorithm. It predicts the CKD stage for a patient by finding the most common stage among its K nearest neighbor in the feature space. KNN is applied in this project to utilize similarity measures between data points for prediction. Support vector machine. SVM is a powerful classification technique. It works by finding the optimal hyperplane that best separates different CKD stages in the feature space. SVM is chosen for its ability to handle high dimensional data and find complex decision boundaries. Voting classifier. A voting classifier combines the predictions of multiple models, example random forest decision tree KNN, and predicts the class that receives the most votes. This ensemble approach often results in improved prediction accuracy compared to individual models. In this project, it's used to leverage the strengths of various algorithms. AdaBoost. AdaBoost is an ensemble method that focuses on improving the classification performance by giving more weight to misclassified data. It combines the predictions of weak learners, that is decision tree, to create a strong learner. AdaBoost is utilized in this project to enhance classification accuracy. XGBoost. XGBoost is an efficient and scalable implementation of gradient boosting. It's known for its speed and performance. XGBoost is employed in this project for its ability to handle missing data and its robustness in dealing with complex relationships in the data. CNN plus LSTM. This is a hybrid model combining convolutional neural network CNN and long short-term memory LSTM networks. It's apt for sequential and image data. In this project, it's used to effectively process imaging data related to CKD. CNN, Convolutional Neural Network. CNN is a deep learning model primarily used for image processing tasks. In this project, it's utilized to process and analyze imaging data related to CKD. CNN can extract intricate patterns from medical images, aiding in accurate stage identification. Training the model. This step involves feeding the cleaned and pre-processed dataset into different machine learning models, including random forest, decision tree, KNN, SVM, AdaBoost, XGBoost, CNN plus LSTM, and CNN. The models are trained on this data, learning the patterns and relationships between patient features and CKD stages. The aim is to prepare them to accurately predict CKD stages for new patients. Building the model. Voting classifier, because comparing to other models, voting classifier gives better accuracy. After training various individual models, a voting classifier is constructed. This classifier combines the predictions from all the trained models. The voting classifier is chosen as it aggregates the collective intelligence of diverse models, often resulting in a more accurate and robust prediction compared to using a single model. FLAS framework with SQLite for sign up and sign in. FLAS, a Python web framework, is employed to develop a user-friendly application. SQLite, a lightweight database, is used to manage user authentication. Users can sign up and sign in to the application, providing a personalized experience. User gives input. Users input their relevant data into the application. This input is pre-processed to ensure it aligns with the format expected by the trained model. For instance, the input is encoded to numerical values using techniques like label encoding, ensuring it can be fed into the model. Predicting the performance. The pre-processed user input is then passed into the trained voting classifier model. The voting classifier combines the predictions from various models based on the input. It predicts the CKD stage for the given input using the collective knowledge of the individual models. Final outcome is displayed. The predicted CKD stage is then displayed to the user. This information provides valuable insights into the CKD stage, enabling both users and healthcare professionals to make informed decisions regarding the appropriate actions and treatments. The ultimate goal is to contribute to improved healthcare planning and better outcomes for HIV-infected patients dealing with chronic kidney disease. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the File Explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax error or logical issues. After running the app.py file, the FLAS framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I'm copying the link. Paste this copied link into any web browser. I usually prefer Google Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. Now click on sign up button. If we are a new user, we need to register first. But I have already registered, so click on sign in button. This is the login form. Here we need to enter the username and the password which we have created. So I'm entering the username and the password and click on login. This is the homepage of the project. So here we need to fill this information to predict the chronic kidney disease and also the stage of the disease. So I'm entering these information. So here I have entered all these details. Gender is male, age is 48, blood pressure is 80, specific gravity is 1.02, albumin is 1, sugar level is 0, red blood cells is normal, pus cell is also normal, pus cell clumps is not present, bacteria is also not present, blood glucose random is 121, blood urea is 36, serum creatinine is 1.2, sodium 0, potassium 0, hemoglobin is 15.4, packed cell volume is 44, white blood cell count is 7800, red blood cell count is 5.2, hypotension, yes, it means the person is having the hypertension, diabetes mellitus, yes, that is the person is having diabetes mellitus, coronary artery disease, no, that is the person is not having coronary artery disease, appetite is good, pedal edema is no, anemia no. So after entering all these details, click on predict to predict the stage of the chronic kidney disease. So here we can see we got the outcome. The patient has non-chronic kidney disease based on the feature values provided. So we can see that this patient is not having the chronic kidney disease. Now let us enter the details of one more patient and check whether that patient is having the chronic kidney disease or not. So I'm entering these details. So here I have entered these details. The gender is male, age is 51, blood pressure is 80, specific gravity is 1.01, albumin is 2, sugar level is 0, that is the person is not having the sugar, red blood cells, the count of red blood cells is normal, pus cell is also normal, pus cell clumps not present, bacteria is also not present, blood glucose random is 106, blood urea is 26, serum creatinine is 1.4, sodium potassium 0, that is the person is not having sodium and potassium, hemoglobin is 11.6, packed cell volume 35, white blood cell count is 7300, red blood cell count is 4.6, hypertension no, that is the person is not having hypertension, diabetes mellitus no, the person is not having the diabetes mellitus, coronary artery disease no, appetite is good, pedal edema is no, anemia is no. Now click on predict. So the outcome, the patient has chronic kidney disease based on the feature values provided. So we can see that this patient is having the chronic kidney disease. So in this way, by entering all these details, we can predict whether the patient is having chronic kidney disease or not. And even in the chronic kidney disease, we have stage 1, stage 2, stage 3 and stage 4. Now click on sign out. The conclusion of the project is the voting classifier and ensemble model achieved high prediction accuracy by combining insights from various models. This accuracy demonstrates the model's proficiency in accurately predicting chronic kidney disease stages in HIV patients. Accurate predictions by the model form the basis for personalized treatment plans, ensuring specific care for HIV-infected patients with chronic kidney disease. The user-friendly application encourages active involvement, allowing individuals to input their data and receive predictions about their chronic kidney disease stage, promoting proactive healthcare management.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.